Hi dear students, welcome back to e-learning class. I am your professor Santosh VJ. Today I am going to teach you next topic of the additive manufacturing process. Today topic is that module 3. In module 3, the title of the module 3 is polymers and powder metallurgy. Okay dear students, today we will discuss about the polymers and the basics of the polymers and polymer techniques. Okay, let's start the session. Yes, dear students, module 3, which includes polymers and powder metallurgy, basic concept of polymers, polymer processing, general concept of powder metallurgy, powder production technique, microstructure control in powders, powder sintering, powder shaping, and application of powder metallurgy. So let us discuss one by one. Let's begin with the definition of polymer. Polymer, which is from the Greek, this word is from the Greek. Poly means many, more means unit. Joined together is called a polymer. Hence, polymer is a macromolecule that is built from a smaller unit, so called monomers. Proteins are built from many amino acids. The proteins are polymers. Amino acids are the monomers. A polymer can be built from the same monomer, so called homopolymer. For example, polytetrafluoroethane. Also can be built from different monomers, so called copolymer. For example, ABS materials, acrylonitrile, butadiene, and styrene. Let's move on to the next slide. Yes, here we go. Clear chart of classification of polymers. The polymers are based on the classified based on the origin of source, based on the structure, based on the molecular force, and based on the mode of polymerization. Based on the source, which we have natural polymers, semi-synthetic polymers, synthetic polymers. In case of based on structure, which we have linear polymers, branched chain polymers, cross-linked polymers. Coming to based on the molecular force, which we have elastomers, fibers, thermoplastics, thermosetting polymers. In based on the mode of polymerization, which we have here additional polymers, condensation polymers. Let's discuss with the classification based on the sources. Here we have natural polymers. The definition of a natural polymer is a polymer that results from only raw materials that are found in nature. For example, proteins, cellulose, starch, and rubber. And second one is semi-synthetic polymers, which are found in artificially, not from naturally. Those are called cellulose derivatives, cellulose acetate. And third one is synthesis polymer. Synthesis polymers also created by artificially. Those are called buna, nylon, polythene, and polyesters. Let's move on to the classification based on the structures, which we have here. Linear polymers consist of long and straight chains. For example, PVC, polyvinyl chloride. Second one. So first one, here we have a figure. This figure indicates that a linear polymers. So as we can see, this is the linear long straight chain. A number of molecules combine together to form a long chain. So this is called as a linear polymer.
And second one is branch chain polymers. It contains linear chain having some branches. As we can see the second image, see, look at the figure here. There are linear long chain is there. The each chain is originates, there is a one branch, so called it is a branched chain polymer. For example, low density polymers. And third one, cross linked chain polymers are form bifunctional and trifunctional monomers and contains strong covalent bonds, for example bakelite melamine. So as we can see the image here, this is called as a crossed chain. So look at the figure here, there is a long chain of linear polymers are there. So in between the two linears there is a one branch that should be connected to the each linear chains, so it's look like a cross link polymers. Okay, next move on to the next category, that is based on the forces, polymers based on the forces. In that, there is one, thermoplastic polymers. These are the linear or straightly branched long chain polymers which can be softened on heating and reversibly hardened on cooling repeatedly. Their hardness is a temporary property and varies with the temperature, which means, dear students, once we heat the kind of the polymers, while heating, which becomes softer, so called it is a thermoplastic material, which are made up of branched straight chains. For example, polyvinyl chloride. Next category is the thermoset polymers. Thermoset polymers are a reverse of the thermoplastics. So the polymers, the kind of the polymer which we heating, while heating, which becomes hard. Thermoplastics are becomes soft. These kinds of the polymers are, while heating they becomes hard. Such kinds of polymers we can call as a thermo settings. See here, thermosetting. Initially, the mixture of reactive low molar mass compounds reacts upon heating in the mold to form an insoluble network. These are formed by the network structures, and these kinds of the thermosets are more stronger than the thermoplastics because those are made up of a strong network structures. Naturally and physically these are more stronger than that of thermoplastics. For example, a backlight. Yes, here I am making some list of the characteristics of polymers. Number one, low density, a low coefficient of friction, good corrosion resistance, good moldability, excellent surface finish can be obtained from the polymer materials, can be produced with a close tolerance materials from the polymer materials, and these are the economically good and poor tensile strength and low mechanical properties as compared to the that of metals and ceramics, and a poor temperature resistance as compared to that of metals and ceramics. Can be produced the transparent type of transparent items are different in colors components. Here we can discuss with application of polymer materials. So application of polymer materials, the first application is in medical field. In medical field, which we can made blood vessels are made up of polymer materials like uh, Dacron, Teflon materials are used to make some medical equipments and medical tools. Second one is consumer products. Consumer products means domestic applications, as we can see in daily uses in our home appliances. These are all these such kinds of the plastics are all made by the uh, thermoset materials and polymer materials especially. And second one, industrial applications. Industrial applications, which means automobile parts, aerospace and aircraft applications, such kinds of industries which we can use the polymer materials to constrain some components and tools. And sports applications, as usually many of the sports applications, we are depending upon the polymers materials, polyground equipments, various balls, golf clubs, swimming pools, and protective helmets. Such kinds of materials are made up of polymer materials. Coming to the next concept, the molecular weight distribution of polymer sample, which includes the following important points. The molecular weight distribution represent the following: represent the frequency of the polymer length. The frequency can be a narrow or broad. The narrow distribution represent the polymer of about the same length. Broad distribution represent a polymer with a varying length. Molecular weight distribution is controlled by the conditions during the polymerization. A molecular weight distribution can be symmetrical. The mathematical representation of calculating the molecular weight. Number average molecular weight, which is represented mn bar. Mn bar is equal to summation of ni into mi bar divided by summation of ni, where ni is the number of molecules and mi is the weight of each molecule. And second one, weight average molecular weight, which is represented mw bar is equal to summation of ni into mi square whole divided by summation of ni into mi. And third one is average molecular weight, which is represented mz bar is equal to summation of ni into mi cube divided by summation of ni into mi square. There is the last one, general equation of average molecular weight. So m bar is equal to summation of ni into mi to the power of a plus 1 whole divided by summation of ni into mi to the power of a, where the addition term a, the viscosity average molecular weight, also makes use of the term a. This parameter is empirical constant that is depending upon the hydrodynamic value. It should be noted that mv and mw are the same when a value has a value of 1. Hope you understand. The mv and mw are the same when a has a value of 1. Yes, this is the graphical representation of distribution of molecular weight in a polymer sample. The nature of the molecular weight distribution. This is the nature of the molecular weight distribution as can be seen from the figure. Mn provides the information about the molecular weight which is present at the greatest frequency in the sample. Mw, so as we can see here, Mw is the weighted average which favors higher molecular weight molecules and appears on the high side of the molecular weight distribution. Whereas mz values has the term mi to the third power, and so it is even more skewed towards the weight molecular weight. The value of the mv range depending upon the constant a. The value of mv range is depending upon the constant a, such that where a equal to 1, this average is equal to the mw. When a is less than 1, is point to be between mn and mw, and the typical value of a is between 5 to 9. Hope you understand this graphical representation of distribution of molecular weight in a polymer sample.
Let's move on to the next topic, polymer processing techniques. So to process the polymers, which we can take the number of techniques which we are going to adopt to process the polymer materials. So here we can take the polymer techniques. As we can see the chart on the slide. So these are the polymer processing techniques.
Here there are two types of polymers which we can use to process. One is a solvent mixture polymer, other one is a direct molten polymers. In case of solvent mixture polymers, which we can adopt the techniques emulsion and suspension techniques. Second one is casting evaporation techniques and hot pressing techniques. In direct molten method, which you can take the which you can take the processing techniques extrusion and injection molding and compression moldings. So let us discuss in detail one by one. Okay, the figure has shown it is a wet spinning polymer process techniques. As we can see, this is the solution vessel. This solution vessels which contains the polymer materials in the form of wet. So these are the solvents and this is the polymer materials are in the form of powders. The solvent is in the form of the liquid. So if these two are in the proper proportion, we mix into the solution vessel, then which are fed into the filter. Filter is to filter the solutions by means of removing the unwanted contaminations present in the polymer solutions, as well foreign matters are removed from the filters. Then pure polymer solution is which are fed into the pure vessel. So once the pure solution is fed into the pure vessel is transfer the solution based polymers into the heat exchanger. The function of the heat exchanger is to uh, remove the moisture content present in the polymer materials. Uh, Once the moisture content is removed by the polymer materials, which are then fed into the filters, the filter once more the here one more filter 2. The filter 2 is to maintain the dryness of the polymer materials by means of removing the moisture content, left out moisture content in the heat exchangers. Then the polymer materials are which are fed into the spin bath. Once it fed into the spin bath, the process of twinning or process of twisting is done with help of the spinnerate. The stretched polymers are finally wound over the rollers. So which means the process is done. Hope you understand how it's work.
Dear students, one more method that is which is dry spinning process to produce the uh, polymer components. As we can see the schematic diagram of the dry spinning process. At the top, which is provided as a tank, this tank is filled by the polymer solution, which are then fed into the spinnerate by means of pump. Once the spinnerate is filled with a polymer solution, then which are fed into the evaporation chamber in the form of thin layers. The function of the spinnerate is to supply the polymer solution into the evaporation chamber in the form of thin layers, then which are then twisted by the spinnerate and which become twisted by the spinnerate to become a thin layer. Simultaneously at the top, which we provide the one inlet, that is air inlet. Through this inlet, the hot air is enter into the evaporation chamber that could maintain the temperature of polymer materials, which means that remove the contaminations, moisture contaminations present in the polymers. They are dried out and these polymers are becomes dry. And at the bottom, which we provide the one more port, this is called air outlet port. That hot air is escape out of the atmosphere from this bottom port. And there are two bottom ports, like left side and right side. That heating jackets are provided that could cover the temperature of the evaporation chamber. At the bottom, which we provide the there are three tensioners are continuously pull the dry fibers from the evaporation chamber, that is in the form of thread or fiber materials, which are then fed into the spool is once starts rotating clockwise direction. This thread type of the fibers are wound over the spool. This is the way which we can going to produce the fiber materials, polymer fiber materials such as polythene fibers, epoxy fibers, uh, polyester fibers, such kinds of materials which we can produce the fiber type of the components by using this dry spinning process. Hope you understand how it works. Dear students, let's move on to the next technique. Okay, as we can see the injection molding, which is one more method to produce the plastic components. This method is most commonly used in industrial applications. Uh, let us discuss with the working principle of the injection molding. Dear students, as we can see on the slide, this is the injection molding arrangements. Basically it consisting of a piston and cylinder arrangement. So piston is moving in forward and backward direction. So at the top of the cylinder, which provides the hopper, at this end the cylinder is provides the heating coils. Those are maintaining the temperature of the cylinders inside the cylinders. At the end of the cylinder, which they are providing the um, uh, bolt box arrangement. Now let's start how it works from the first step. The first step is the powder form of the polymers are dumped into the hopper. That hopper is supply the powder materials into the cylinder. Now the piston is moves in the uh, forward direction. These polymers are which are this piston is pushes the polymer materials, then which are fed into the injection chamber. Once they are fed into the injection chamber, they starts melting. They are turned into a they are turned into the solution. So again the piston is moves in the same direction. These solutions are again fed into the mold box through the nozzles due to the moving action of the forward action of the piston. Once the molten polymer materials are enter into the mold cavity, entire mold cavity is filled by the polymer materials. Once the process is done, this entire mold arrangement is separated from the uh, cylinder arrangements. Then the it means the curing process is done. After the curing process is completed, the raw materials curing process is completed to separate the mold boxes with the help of the ejection field. Then you can remove out of the finished product. That finished product is let's next move, send into the further finishing operations. So this process is mainly used to produce the structure type of the components such as billets, seats, uh, some tube type of structures. So basically for the industrial application as well as domestic applications. Hope you dear students how it works. This is the most common method used in industrial applications. Thank you. Let's move on to the compression molding technique. This technique is most commonly used to produce the polymer components. Dear students, as shown in the figure, the compression molding arrangements, which is the most common method used to produce the polymer products. As we can see, the image 1 indicates that molding arrangements. There are two mold portions, which are upper mold box and lower mold box. The upper mold box is also called as a cope or punch, whereas a lower mold box is called as a drag, which are then designed by as per the required shape and size of the component. And this figure 2 is indicates that the cope is a contact with the drag by means of external force, which means the compression process is done and it continues till the object is formed. And figure 3 is indicates that collection of finished product from the mold box by separating the mold box. Later on the finished product is will be sent to further finished operations. Okay dear students, I hope you understand how it works, the compression molding process. Yes, the next one is the blow molding method. So in blow molding method, as shown in the figure, there are four steps which are involved in the
blow molding process, which are going to explain how the blow molding process techniques works. Step 1 is, as we can see, indicate that the barrel which supplies the plastic resin to the mold box from the top end, whereas a bottom end which is provides blow pin. Second step is indicates that, as we can see, the pressurized air is entered into the mold box by means of blow pin till the required shape is formed. As we can see in the third step is indicate that the blowing process done, which means the required shape and size of the component is formed in the mold box. As we can see, the fourth images indicate that the finished component is removed from the mold box by separating the mold box and blow pin is off. So, dear students, I hope you understand how this process is begins and how the process is ends. These kinds of the components which we are going to manufacturing through this blow molding technique.
Hi dear students, this is the last technique to produce the polymer components, which is a very simplest and most common method. This is also a simplest and most common method. This is called as open mold technique, or also called as a hand layup process. So as we can see here, there is a first step is the selection of the mold box. The selection of the mold box is depends upon the quantity which we are going to produce, the quantity of the finished product, or shape and size of the finished product which we are going to manufacturing. Based on that, we have to select the mold box and keep the mold box in proper place and clean the mold box thoroughly. After cleaning the mold box, we have to apply the release gel over the surface of the mold box. After applying the release gel, now we have to select the reinforcement material. Most commonly, the reinforcement material in the form of fibers. These fibers are cut and those are fed into the over the surface of the mold box. Then we have to select the resin. This is a matrix, it act as a matrix. So this resin is made up of most commonly the epoxy resins. This epoxy resin is pour over the surface of the reinforcement. After pouring process is done, the ruler action is begins. The ruler is roll over the surface of the resin, which means there is a close contact between the reinforcement and matrix materials. Once the rolling action is finished, now we can remove the finished product from the mold box with the help of the release gel. Hope you understand how the hand layer process is begins. Why we are calling is the hand layer, because here we are not using any uh, mechanisms and any power source operated equipments. It is done by human hands, so called it is an hand layer process. Okay dear students, as we can see on the slide, this is a one more technique which is called filament winding process to produce the fiber components. The first step is to select the material as per the required dimensions, then apply the gel, keep it ready. In this process, the standards of fiber reinforcement in fed through a plastic resin bath, and bath supported by the carriage. The fiber resin wound on the suitable rotating mandrel in a predetermined orientation, while the mandrel rotates and rolls up the imprinted fiber. The transversing carriage runs along the length of the mandrel with help of track. The filaments are wound along different orientations so as to utilize their strength in an efficient manner. Application for this method includes turbine structure, chemical and fuel storage tanks, and pressure vessels. Hope you understand how it works. And as we can see in the figure, so this is the mandrel and this is the track. This track will be moved to and pro motion. This is the standard, as I told earlier, this is the
mandrel. So these are the reinforcement material. Those are continuously fed into the resin bath. Resin bath is a container of epoxy resins. Once these resins are fed into the resin bath with the help of the tensioner, the resin is applied to the entire uh, polymer fiber polymers. Then this resin bath is supply the fibers to the mandrel. The mandrel is continuously rotated in clockwise direction, but by means of mandrel rotation, the fibers are wound over the mandrel. uh, this process will continue, this rotating process will be continue till the entire fiber is wound over the mandrel to complete the finished product. The track is track is the track this track is helps to move the mandrel uh, back and back and forth motions. Hope you understand.
Okay, now I will stop this session. We will continue to the left out topics in the next session. Thank you.